In this video, we're going to demonstrate how to run a sample using the X-ray diffractometer. The sample that we currently have loaded into the system, as you can see from the video, is a copper powder system that is mounted, or a copper powder sample that is mounted to a standard glass slide used for optical microscopy. If you have a small amount of particle sample, or your samples, your grain sizes are extraordinarily small for the particles, then you may choose to source a zero background slide so that it will lower the amount of noise that is generated whenever the glass slide scatters the X-ray signal. For this sample, a standard optical microscopy slide will do just fine. So in the software, we're on the computer, we're going to open up the program called Data Collector. To do that, we're going to double click this icon and it will open up the Data Collector software. Put in our username and password. And it opens up the software initially. The first thing that we'll want to do is actually connect to the XRD system. To do that, we're going to choose Instrument, and we're going to tell it to connect. So I'm going to click on Connect, and there's only one option from the user interface that pops up, so we select OK. And then we see that it is connecting to the XRD system. Comes up with the standard information window. If there were any red X's or any red columns, we might take notice to that, but this is just information on the system, so I'm going to say OK. And now it opens up with the instrument configuration pane on the left-hand side, and we are ready to turn the system on and to start measuring our sample. We are assuming in this video that you have already loaded the sample and that you have securely shut the doors to the X-ray diffractometer. That is probably one of the most frequent errors, is shutting the doors either too hard or not securing them both at the top and bottom, and that will cause a limiting error and not allow your scan to proceed whenever the interlocks cannot properly engage. We may see that in this program, but hopefully we have properly shut those doors on top and bottom. To turn the X-ray generating source on, we're going to double click on the icon under X-ray called Generator. Double click that one, and the tension that we always set the X-ray sample to, or the X-ray generator to, is an acceleration voltage of 45 kilovolts along with a current of 40 milliamps. This is standard. Everything else we leave as the default settings. We'll say Apply. And on the front of the X-ray generator of the XRD system, we see that the acceleration voltage and the current have both been adjusted to 45 kilovolts and 40 milliamps respectively. So I'm going to say OK. That has turned those two values up so that we can now start measuring our sample. To measure our sample, we're going to use a program for that. And the first thing we might want to do is to quickly review what the starting and ending angles are. To do that, we'll go to File and select Open Program. The most frequent way to run an XRD scan is to use a predefined program to make that measurement. The one that uses default scan parameters is the first one listed, called XRD Default Scan Parameters. Double click that one, and it opens up, and we see a couple of things listed here. Number one, it is a continuous scan. For a continuous scan, it's going to continuously sweep the arms on the XRD system to move through the angle limitations that you have set. And we have told it to start at 5 degrees. That is the smallest angle that can be measured with our powder X-ray diffractometer. Anything less than that will just generate noise, and so it's best if you just start at 5 degrees or higher, depending on the material and its respective peaks where you expect to see those occur. The end angle for this scan is set at 100 degrees. This provides a fairly large scan over a large angle. The step size is 0.02 degrees. And what this means is that over this angle, the 0.02 degrees, it will average that information to give us the spectrum data that we want as a result. And that's because this is a continuous scan. If this was a step scan, it would simply move in these increments and only look at the data at that incremental angle value. The time per step here is set at 5 seconds. This is a little slower than some of the this is a little faster than some of the default scans that are set up originally, and that's because we have increased this angle sweep just to give us a quick scan of the materials that we're interested in viewing. So with that, those are some of the defaults that we can put into there. We also have a repetition page, which allows us to do multiple scans one after another, and then the software automatically adds those scans together. Currently, we have the number of scans just set to 1. So we might want to change that if we had some small peaks that we wanted to identify. These all look like good settings, and we are ready to start our standard scan. So I'm going to close this. And if we had changed some of those settings, it would have asked us to save it when we hit that close button.